Hi, welcome to the first video in Physics 30S. Here are the outcomes for this first unit, and we're going to be taking a look at this one first here, this experimental design. So if we move forward to where we're actually going to be doing our notes, we'll be here, how to design an experiment. So we're going to learn how to identify and how to classify independent, dependent, and controlled variables. And just before we start, I'll mention about how our labs generally, when we write them up, generally all start the same. To graphically and mathematically model the relationship, or sometimes relationships, sometimes one relationship, sometimes more than one, between, so that's how it starts off. I'll give you a second to write that out, and we can abbreviate that to graphically and mathematically model the relationship between. So we start that off. Between what things? Well, I'm just going to pop down to the bottom where it has this example of a pendulum and think about what were we testing. Well, we were testing the angle, or sometimes we call it the amplitude, either way, like how far back we pull it. So if we were to start from here, this would be some amount of angle, versus the time to go back and forth, which was the period. That was one relationship that we're thinking about. The second one relationship we were thinking about is what happens if we change this length here. I'll put an L there, length versus period. Again, it's that back and forth. And the last one we were thinking about was this thing on the bottom. What was the mass or the weight? I think in class we said weight versus period. So what happens if we change the angle? What happens to the period? So these were the three ways. I've kind of started this sentence up here and kind of ended it down over here, right? So to graphically and mathematically model the relationships between angle versus period, length versus period, and weight versus period. So in our example that we're learning how to do this, we're kind of doing a complicated one. We're doing three at once. Now you'll notice how I put period second and I put all these different things first. So you'll notice that when we design the experiment, there's one of these things that we get to set. We get to pick where to put the pendulum to begin. We get to pick the angle, and then we measure the time to go to do the back and forth. We measure the period. So this first category here, I'm going to give a name for that. I'm going to call this the independent variable. In fact, this is our note over here. So let's go and write down what independent variable is. And I think the easiest way to say is that we get to decide the values. So like I said before, when we set up the experiment, we can decide all the different angles. We can do one at 5 degrees, 10 degrees, at 20 degrees. And then the dependent variable, the second one, the period in our example, would be we measure to find out the values. Hopefully this language about dependent and independent makes sense because, oh, there should be an E, I think, here. Because the dependent variable, in this case the period, the time for back and forth, the time for back and forth depends upon, well, how far away you started it, or perhaps what the length of the string was. So the word dependent really helps. Period. What the period ends up being, how long it takes to go back and forth, depends on how we set the independent variables. Now, if angle and length and weight all have an effect on what the period is, if we want to isolate and just say, well, how does angle make a difference, we better keep everything else the same. And that's what the controlled variables are. So really, we want to keep everything else the same. Let me pick a smaller. And when I say keep everything else the same, the things that we think make a difference and even the things that we're not sure. So here is our example, right? It's the pendulum example, and that's the one we're doing in class. So to talk about these three examples here, so when we do angle versus period, this would be our independent variable, this angle. This would be our dependent variable. I'll just erase this. And what would we control? So we would control, in other words, keep the same length and weight. And so on. So when we do number 2, our independent variable would be length, and our dependent variable would be period, and then we would control angle and weight, and so on. All right, let's take a look at the next page here. It says, this is a practice, so for this practice, you read over the 3 examples and you try to do those yourself, and there will be answers here so you can check to see how you did. If you had any problems, come and see me. So let's go right along to data collection. So here are the things that you're going to learn in this unit. You're going to learn to select appropriate measuring devices, and I think it's not too hard in this method. The period, the back and forth, you're going to measure with a stopwatch. The length, you can use a meter stick, and so on. The second one says consider accuracy of measuring device and significant figures. So I can talk a little bit. I won't talk too much about significant figures now, but I'll just give you an example. So if you are if you're measuring this, right, and you've got a meter stick, and your meter stick measures to the nearest millimeter or something. Let's say you take a look at this and you measure, and it is, I don't know, 45 centimeters. And on your meter stick, you can actually measure to the nearest millimeter. That means that you knew that, remember, a millimeter is a tenth of a centimeter. So you could actually say 45.0 centimeters. So I'll just write a couple notes down the bottom just to summarize things. So first of all, accuracy really counts. So when you are conducting your experiment, use a method which is going to make things more accurate. For example, I think I'll go back to green. For example, we did either 5 cycles, and then we divide by 10 or divide by 5. That reduces the error in trying to calculate the period. Or you could do 10, even too. You could do 10 back and forths, and then divide by 10 as well to make things a little bit more accurate. Yeah, and then show accuracy. In your numbers. If you are able to measure to the nearest millimeter and you are writing down centimeters, 45.0 centimeters versus 45 centimeters, this one tells me that you measured accurately to the nearest tenth of a meter, or tenth of a centimeter. Oops, I can't spell. Let's try this one again. Tenth. This one tells me that you only measured to the nearest centimeter. If you can measure to the nearest tenth of a centimeter, if your meter stick actually has marks every millimeter, and they do, then you should include this 0, or if it's not a 0, you should also include it. The other one is you should pick the range of values. So when you pick what the angles are, or when you pick what the lengths are, the range of values for independent variables. You know what, I'm just going to give myself some room here. I'm going to erase all this. Okay. Range of values for the independent variables, and by that I mean the angle, the length, and the weight, the things that you get to pick, should be at least 5. In other words, the largest angle, the largest, divided by the smallest, should be greater than or equal to 5. So if you pick one length that is, say, 100 centimeters as your largest, your smallest one should be at least 20 centimeters, if that makes sense. So 100 divided by 20. And then you can pick values that, as much as you can, go evenly from 100 to 20. And again, at least 5. If you can design your experiment so it's greater than that, that's great. And I would say how many values should you pick? So if you're going to pick between 20 centimeters and 100 centimeters, you should do usually between 8 to 10 data points. And make sure that you're measuring in metric. So where should all these numbers go? Well, they should go in a data table. So you're going to be learning how to construct and how to label a data table. First thing is when to record your data. Raw data should be recorded as it is collected. So right away is the answer. So I would recommend you organize your data table first. So use a ruler, draw out a nice table, get it all ready. Use pen, not pencil. So what happens if you get a bad number? And I may have mentioned this in class. Let's say you're measuring angle in degrees, and you got period over here in seconds, and you pick 5 degrees, and I don't know, maybe you think you screwed up and all your other numbers was like 2.6 seconds, and all of a sudden you got 26 seconds, and you thought, that's crazy, it's different than everything else we did. Just try doing it again. So you can either put another one here at 5 degrees, and then say you get 2.6 seconds, and you say, oh, that sounds better. Leave your original one and just put a single stroke through it to show that you actually collected it, but then you're going to disregard it because it just didn't fit with everything else. You can even, you could even give yourself a little note here. You could say timing mistake for the reason why you got it wrong. Okay, so here's how a table should look. Now, obviously, this is printed out, and yours is going to be done by hand. I would say it's a good idea to use a ruler to make your data table. It's a good idea to make it sure that it's neat. A couple things I want you to notice is that they've got the units here, and they've got the units here in the first line, and then you don't have to write grams every time else, right? So if you just put it at the top, you don't have to do it continually everywhere else. You'll notice in this one as well, they've got mass and they got time for 10 swings. You're going to end up having to do another calculation. So what I would actually recommend for this one is to have a third column here. So you've got time for 10 swings. You could say time for 1 swing. Or you could say average time for 1 swing. So how are you going to do that? Well, you've got these 3 values. They did this 3 times, which is a pretty good idea, and they did for 10 swings. But we're interested in not what the time for 10 swings is, but we want to know the time for 1 swing, for 1 back and forth, for period. So then they would have to do some calculations. So here's where they did their calculations. They figured, okay, what's the average time for 10 swings? So they would add the ones together and divide by 3, and they would say, okay, and then they would round it off to the same number of digits that they had to begin with. And then, so I would actually, at the end of the day here, you got 15.64. If I was to put it in this column, I would say divide by 10. So 15.64 divided by 10 is 1.564 seconds. So that would be, from this, we had to do a calculation. So show your calculations at least once. So here's an example of your sample calculations. And my goodness, you don't have to put so many words. Just show your work that you did once, that you divided it, and I think that would be pretty good. Okay, so I think that pretty well covers it. I got so much white space in here, though. I can, do a couple notes of things I talked about. I'm not too picky on this, but the independent variable goes first. Again, mass was something that we got to pick, and then so the dependent variable can go afterwards. So in the first column versus a different column. This first one here has the head headings should be name a variable, in this case mass, and then in parentheses the units. So G stands for grams, and that's the units. I'm going to just add as many points as many data points as possible. Uh, 8 to 10 is a good minimum. How many did they do here? Well, they did 1, 2, 3, 4, 5, but they did do a set of 3 all the time. So really, they could have done a little bit better here. In the case that they would only end up with 5 dots. So I wouldn't have minded if they'd done, instead of jumping by 20 each time, they could have jumped by 10 or something, or 15 even. And the independent variable range. So again, this is the largest divided by the smallest should be greater than or equal to 5. So this is a good example. So when you're picking like which value should we put, what masses should we put on there, you should have the largest divided by the smallest to be at least 5. Okay, well I hope this was helpful, and that's all we have for today. I'll talk about that in our next video. So thanks for watching, and I will see you in class.